Hey, what's going on? I'm Will from DevOps for Developers, and this video is going to start off like it's not DevOps related, but it really is in a really profound way. So stick with me for just a couple minutes and we'll get there. The other day I was working through this video learning to play the guitar solo from Ozzy Osbourne's Crazy Train, and the guy doing the video goes off on this little bit of a tangent talking about how he had watched Randy Rhoads play this solo hundreds of times, and it seems like he almost never played the solo the same way twice. And the reason he was pointing that out is because a lot of people learning to play guitar get hung up on, memorizing, oh, I gotta hit this note, now I gotta hit this note, and it's gotta be note for note perfect, when in reality, it's more the spirit of the solo that's important than the note for note solo itself. It's better to modify the solo for the environment that you're in and put on a good performance than to only be able to play the solo 90% of the way through and not be able to finish it, because then you're left hanging. And this really struck me because it's relevant to DevOps too, because in a lot of cases we get tied up on looking for exact scenarios of how to perform a specific task, right? I'll give you an example. The other day I was building out this Kubernetes deployment for an application I've been working on. This application, it receives a message from a message queue, and it contains some parameters telling it what type of Kubernetes environment to launch. The message contains the amount of CPU, the memory, the GPU, the Docker image to use, and a varying list of volumes that need to be mounted to this container. And so this environment gets launched, and then that creates a specific URL that then someone on a different team can connect to this instance and do some data manipulation using those volumes that are mounted. So the problem I was facing there was inside of the stateful set, I was looking to do multiple volume claim templates. So if you're not familiar with a stateful set in Kubernetes, it's basically a YAML definition of what you want the Kubernetes to build. So it's a definition of, I want a replica set with this many replicas. Each replica should have these containers. The container should have this much memory and CPU, and should have these volumes mounted, and the volumes come from this persistent volume claim, and that persistent volume claim is specified in a persistent volume claim template. And I couldn't find any examples anywhere of someone specifying multiple persistent volume claims, right? And I even went back and started digging through the API docs for Kubernetes itself, and according to the docs, that template is an array, so we should be able to put multiple items in there. But every time I did, it would fail validation when I would try to run the template on Kubernetes. And of course the option there was to disable validation, but I was like,
no, we're not sending something to production that specifically disables validation.
So I was stuck. I had this thing that should work according to the documentation, but I couldn't get it to work and couldn't find any examples of anyone else getting it to work. So I was kind of at this sticking point, and that's whenever I started thinking back on this video that I'd watched and realizing it's not really the specific implementation, it's the spirit of the implementation, right? I wanted the volumes mounted. How they got mounted, I really didn't care. It looked like this was a path to do it, but it wasn't really working out for me. So I fell back and ended up just creating, in my YAML manifest for Kubernetes, I created persistent volumes and persistent volume claims that matched up to the mounts that I specified in the stateful set, and it all worked out fine. And so I think that's really the point that I want to drive home in this video, is not to get so hung up looking for an exact reference to follow, anything from like something to copy and paste from Stack Overflow to looking for blog posts that specifically state your problem or videos that specifically state your problem. Instead, just think about what your end result is going to be, where you're at, and how you can get there. And then, of course, your learning path is going to take you through different things. Some of those might work exactly. Some of those might get you to a certain point when you have to turn and twist and try something different. And that's just the nature of not only DevOps, but software engineering in general, and IT and the whole technology ecosystem or world that it is. We try and we fail and we try something else. And that's usually what our path to success looks like. It's a whole lot of failures with one at the end that accidentally didn't fail. So that's just something as a person new into this industry that I think it's good for you to know. Failure is just part of the job. And the cost of failure these days is pretty low. Like these days, if you fail in your implementation of something, it's either just going to crash or, possibly it could launch and run out of control and consume all the resources on its host server, in which case you just kill it and try again, right? Nobody actually got hurt from that, and it didn't cause any real damage. Versus if you think back to whenever I first got started doing this whole career thing back in the early 90s, whenever we had to change something, it usually meant pulling a server out of the rack and then installing new hardware. And back then the hardware was super sensitive to electrostatic discharge, and most of the time you had to set these different jumpers to assign the memory address space before you put it in. And so then you put it in and it wouldn't work, right? And you had to think, well, did I accidentally shock it and blow it out? Or did I put the jumper on the wrong setting? If I put the jumper on the wrong setting, did that blow out the motherboard? And occasionally, depending on where the failure was, you would get the motherboard or the BIOS would give you certain beeps to tell you where it thought the problem was. But in my experience, either I was in a noisy data center where I couldn't hear the beeps, or the beeps never happened at all for whatever reason. And so then you had to pull this hardware out and figure out,
okay, did I just fry the hardware, or did I just put it in wrong? What do I do next?
And sometimes you would have another server sitting there running. You think,
well, I could shut that server down and plug the hardware into it to see if the hardware is any good.
But at the same time, if the hardware is bad and you plugged it in there and then it fried that motherboard, now you got two dead servers. And so the cost of failure there was higher because there was actually monetary value tied to your trial and error troubleshooting. And that's not the case these days. Most of the time everything is software driven, so you just try it, watch it blow up, laugh a little bit, make notes, and then move on with your next change. So I hope that was helpful for you. I think the point I really wanted to stress with this is that trial and error is just the nature of the beast. It's our path to success. And it's not really so much about doing DevOps, but just doing DevOps isms, if we want to make that a word. So we kind of try something DevOps-ish and then, move forward or back based on what we learned from that. So let me know your thoughts in the comments, and check this out. For those of y'all about to deploy, we salute you. And for those of you not about to deploy, you can pick up a copy of my new book, The DevOps Career Guide, because it contains all of the skills that you're going to need to eventually master in order to be successful at DevOps and get to that deploy stage. All right? That was subtle, yeah? It was a subtle sales pitch. I thought so. I thought it was pretty damn clever. All right, I'll see y'all next time.